Flip this page horizontally. There you go. Okay, so we're on page 13. We're just continuing on with the transformation of functions. It seems like this is going to be a short one, but I'm actually going to go and talk about what your fellow classmate here had asked. Okay, so example 8. Let's read it first and see if we understand the question, okay? So determine the coordinates of an image point after a horizontal stretch or compression. So they're really not telling us what's going on. They're saying that it's going to be either horizontal stretch or compression. We'll see. So it says here, a point that is in 4, -9, 4, -9, lies on a graph of y equals to f of x. Well, we don't know what f of x is. We don't know what the graph looks like, but we do know for certain that this point is in that particular graph. So what are the coordinates of the image A prime? This is A prime, on the graph that's negative f of 0.75 times x. Okay, pause for a second. What, in our language of math, what is our transformation here? What kind of transformations happening here?
It's a reflection.
Okay, so what is this called here? This is called a, yes, reflection. Which one? Because we have two different kinds of reflection. Vertical. So there's going to be a vertical reflection over, okay, because if it's right there, over x-axis. Okay, so this negative sign right there, we know that's going to be a reflection, vertical reflection over the x-axis. Sometimes different text calls it about the x-axis or over the x-axis or in the x-axis. So now what else? What does this mean? Okay. Is that affecting the x or the y? Is that compression? It's going to be, yeah, so this is the B. So this one is going to be horizontal stretch. Very good. Stretch by a factor of what? Okay. 3. Okay, so 0.75 is what? 3/4, right? But remember, it's going to be 1 over B. 4/3 by 4/3. Okay, let's figure that out again. This is going to be a horizontal stretch, stretching horizontally by a factor of how much? 4/3. And where did we get the 4/3 from? Okay, because 0.75, I'll just write it over here on the side. 0.75 is equals to 3/4, right? And then this is going to be 1 over B. And if you take the 1 over B, let's just take the reciprocal of 4/3 or 3/4, which is 4/3. Okay? So, okay, if that's the case, What is the image? Okay, let's see. So yesterday we were introduced to the idea of mapping, right? Let's see if we can picture that in our mind. The point is at 4, -9. 4, -9. So 1, 2, 3, 4. -9. 1, 2, 3. Okay, well, somewhere right there. I'll call that 4, -9. What happened there? This got reflected up and then stretched horizontally. Okay, so what's happening there? The vertical reflection, this becomes 4 9s, 4, 9. The vertical reflection that's affecting this one, right? The 9. And it's going to be multiplied by -1. So -1 times y. And then this one, 0.75, that's affecting the x. So that's going to be 4/3 times x. So our new point would be 4/3 times x. Well, what's 4/3 times x? 16/3. And then negative y. So it's going to be -9. Okay. So it's going to be reflected down, stretched a bit.
The original point is at -9. So
Oh, yeah.
Oh, it is -9. Sorry. Yeah, you're right. I wrote it wrong here. So it should be -9, then that would be +9. Thank you. So it would be reflected the other way over the x-axis and then stretched a bit. Okay? So this one here, I had to scribble this out because this is not the right one. We're going to replace it with g of x. Y is equals to g of x. What are the coordinates of the image on the graph that says 2 times g of -5x? Okay, let's see. Okay, remember we're all language learners of math here. What's the right terminology here? How do you read this? How do you read it? What does the 2 mean? That one is which one? Vertical, horizontal? Vertical, okay. Vertical, is that vertical stretch or compression? Stretch. Okay, by what factor? By a factor of 2. 2, okay. So that's going to be a vertical stretch by a factor of 2. Is everybody okay with that? Vertical stretch by a factor of 2. So that means the y will be multiplied by 2. Now let's see the inside here. What does the negative mean? Okay, reflection where? This is going to be a horizontal reflection over where? The y-axis. Okay, so some places or some books would say it's just a horizontal reflection. They know exactly that it's over the y-axis, really. Okay. Okay, so that deals with that negative there. What's the 5? What's the deal with 5? What is it called? Is it vertical, horizontal? Horizontal. Okay, so this is going to be horizontal compression by what factor? A factor of 1/5, because the inside number there, the B tells you it's going to be 1/B. So 1/5. Okay. So we know what kind of happened to the point, right? -1/2, 6. So -1/2, comma 6. What's happening? We're going to vertically stretch by a factor of 2. So this is affecting the y. So it's times 2. Whatever the y is, it's being multiplied by 2. Is everybody okay with that? And then there's a horizontal compression of -5 and also going to be multiplied by negative. So it's going to be really saying it's going to be -1/5 x. Is that okay? 1/5 times x. Okay, so what's that going to look like? So if this is x, and if you multiply it by 1/5, what would it be? It's going to be positive 1/10. It's going to, did it get compressed? It used to be 1/2 and then it became 1/10. It got compressed more, right? And what about the y? 2 times y, which gives us 12. So it's 1/10 or 0.1 comma 12. Okay? Good? How's that language going? Well, let's see here. I want to put something on top in here. Maybe I should do that. So if this is your x comma y, and if you're transforming it, it's basically happening like this. X over b, x over b, and then the other one would be a times y. That's what the transformation is. See here. The graph of g of x is the image of the graph of y equals f of x. Okay, so this is f of x, and then the g of x is the image after it's been transformed. Corresponding points are labeled. So if this is b, and then this is the b prime, so that means that's a transformed one. This is a, and this is a. Okay. Write an equation of the image. And you look at that one. This is kind of interesting. Any guesses what this is going to be? Is it vertical stretch or horizontal compression? Stretch? Compression? Compression? Okay. I'm not saying yes or no. I'm letting you just look at that piece and say, what's going on with that piece? Okay. Now this is what's going to help us, okay? Okay. I'm not sure. Okay. Maybe, okay. Tell me if this is going to help. You know, like I think during the test or an assignment, you're going to go like this. I can see one student was like, oh, I'm going like this. What's going on? Okay. I'm going to put something. Maybe this will help you a little bit, okay? Your original B. What's the coordinate of original B? +2, 2. Okay, +2, 2. That's your B. What happened? What's the B prime?
So it's
2 and 6. Okay. Now, let's do A while we're at it. What's A? 5 and 1. Okay, so 5 and 1. And then A prime is 5 and 3. Okay, good. Now, does that help you a little bit? Okay, now tell me what's going on. Okay, I'm not saying yes or no. So somebody says vertical stretch. Okay, so I'm thinking now 2 people said vertical stretch. You can still say no. Don't give in to peer pressure.
Well, we said we're multiplying the diagonal by 3, but if we go back into using the form,
Did the x get transformed? How do you know that? How do you know that? What stayed the same? X coordinate, right? That's 2 and 2. Didn't change. 5 and 5 didn't change. Good. Oh, finally, I made her talk. Okay. So what did change? The y. Okay. So it used to be 2, now it's 6. Used to be 1, now it's 3. So what's that?
being multiplied by 3.
Okay. So that means it got multiplied by 3. Okay, so that means A times Y is equals to A times Y. That's your Y X, right? X, A times Y. So A is equals to 3, right? It's multiplied by 3. So what is the equation? What is the equation of the transformation? Y equals 3. It's a vertical, right? G of X. Or F of X. F of X. It should be F of X. I have too many letters. So the G of X is really 3 times F of X. Okay. Good. How do you like that? It's fun, right? Okay, let's see this one. Oh, is that it? Okay, good. Example 10, last example. The graph is y equals to g of x is the image of the graph of y equals to f of x after the transformation. The corresponding points are labeled. Write an equation of the image graph. Okay, I'm going to ask you again. Is this a compression or stretching? Did you say reflection? Reflection, so there's to get reflected. Horizontal stretch. Okay, remember this is the original one, and now it's over there. You're okay. I'm not saying yes or no. So one person said horizontal stretch. Horizontal stretch. Anybody else? Anybody else's?
Of 1/2.
Of 1/2? Okay, we haven't quite figured out if it's a horizontal stretch or is it a compression or is it vertical? It's vertical? Okay, well, I don't know. I'm not saying yes or no. Okay, now what can we do? Coordinates. Let's figure out the coordinates. So B, this is your original B. B is what? Negative 2, 6. Now, it's been transformed to B prime. B prime, where is that one now? Negative 4, 6. Yes? What about the other one? Point A. Point A is 1, 0. And then A prime is negative 2, 0. Okay, now does that help a little bit? This is a single transformation. What's,
Just 2 minus negative 2.
oh, 2, 0. That's what I meant, the other two. What do you think? Is the X changing? Is the Y changing? No. So the Y stays the same. So there's no vertical stretch there, but there's a stretch for the X. Okay, so what's a stretch for the X? 2. Okay, so there's a horizontal stretch by a factor of 2. Okay, horizontal stretch by a factor of 2. So that means, what's the equation? Y equals f of, okay, it's going to be the reciprocal. So f of 1/2 x. So is it good? How did I get 2? Yeah, so it's a horizontal stretch. I said 2 by a factor of 2 because I had to take this number and multiply it by 2 to get that one, right? Negative 2? Negative 2, 6. So to get the like negative 2 is what you started off with, and then you got a negative 4. So I had to multiply it by just 2, right? Negative 2 times 2 will give us negative 4. Is that what you're asking about? Yeah. So are you thinking negative 2? How did we get to 2? Okay. So if you take a look at this one, this is your original one. How much do you need to multiply to get the 4? Yeah, times 2. Yeah, times 2. So it's been multiplied by 2. Okay, so that's a factor of 2. But then when we're writing it down, when we have to write it down in here, the B is going to be, the factor would be 1 over B. So if this is 2, that means, if this is 2, that means it's going to be 1 over 1/2. So the B is 1/2. So if we do that, 1 over the B will give us the 2. Is that good? Did I answer your question? Yep. This is a confusing one. Because when you think of like a factor, and if you multiply by 1/2, isn't it supposed to be getting smaller? But not in this case, because we want the reciprocal, 1 over B. Okay, Good. Stop. I'm not quite stopping there. Okay, I'm not quite stopping there. What we're gonna do something a little bit different. So you would have to. I'm not gonna continue on with the booklet. I'm actually gonna continue on with just the regular notes. So I'm gonna ask that. Can you just take a few of these things here? Just pass it around. We're gonna do some stuff. Well, maybe two, take two or three, maybe three graphs. Everyone got one? Or a few? Business, most of the question looks like this. Y equals to f of x. Right? Most of the things that we see are y is equals to f of x. The question is like, what is f of x? F of x could be different things, right? So I'm going to start with y equals to x squared. So f of x is your x squared. What if you have this? Y is equals to square root of x. And what's your f of x? Root of x, right? Anybody know what this is? Absolute value of x, right? So our f of x is the absolute value of x. Okay. But there's other functions too. There's what I'm going to do. So I'm just going to focus on some of these things. So these are what we call a parent graph. Oh, let's do one more. 1 over x. Oh, we know this already. That's also a parent graph. So what we're going to do is we're going to say, we'll start off with the x squared. Okay, so starting with x squared. Y equals to x squared. What if we say we want to do this? Y minus 1 equals to f of x. How do you do that? We know that f of x is now x squared, so how do we do that? So you're going to substitute x squared right here, right? Okay. So this one would really, what's happening in here? This is a transformation. What's happening here? One what? Up 1. Okay. So if I put that there, you're going to get y minus 1 equals to x squared. What does that look like? What does that look like? Well, let's see. If this is your graph, can we graph this one right now? Yeah, what kind of graph are we gonna get? Parabola, right? Okay, so let's graph that. So y equals to x squared. So if x is 0, y is 0. If x is 1, what is y? We're graphing this one. 1. If x is 2, 4. If x is negative 1, we're graphing this one. If x is negative 1, put negative 1 there. 1. If x is negative 2, 4, y is 4. So this is what the graph of that. Right? Now, this graph was transformed into y minus 1 equals f of x. But we know f of x is x squared. Okay, so what does that mean? Shifting down 1 unit. Shifting up 1 unit. One unit. Okay. So if we shift this up 1 unit, what would it look like? This is going to be up 1. So every single point, x stays the same, but y moves up 1. X stays the same, but y moves up 1. Is that okay? Good. So when you see f of x, it could be a variety of function, but we're going to look at the function x squared. Now let's take a look at this function. Y is equals to the square root of x. Okay, this is a parent graph. We're going to graph y equals f of x minus 1. Actually, yeah, x minus 1. What does that look like? If we put it in terms of the square root of x. So it's going to be y equals to, so instead of x, we're going to put in x minus 1. So this is going to be x minus 1. What kind of transformation is this? Horizontal translation, shifting 1 unit to the right. Perfect. Okay. Well, what graph does this look like? If x is 0, y is 0. If x is 1, y is, we're doing this one for now, okay? The parent graph. When x is 1, y is 1. I'm going to skip a bit. I'm going to use the right, like, nice numbers. When x is 4, y is 2. 1, 2, 3, 4, 1, 2. Okay, what does that graph look like? Do you remember graphing this in a different way last time? Remember how you graphed it before? You just graphed the linear function there and then you took the square root. That's what you did before, right? Okay, so this is what the parent graph looks like. And this one here, what's happening in here?
I should do
What? Yeah, shift right. Shift 1 to the right. Okay. See, it's affecting the x. So this is going to be now over here. Every single point is moved to the right. Good. Is it okay, or can I move it to the next page? Let's take a look. What's the next one? Y equals to the absolute value of x. Okay, so that's what the function is. Now this is what we wanted to do here. You want to go y equals to 1/2 absolute value of x. I think this might be my last one. Okay, what's happening there? Is this A or B? Okay, so here, let's take a look. This is the f of x. This is the f of x. F of x. So that's the, this one is A. Yes, A. Sorry, I couldn't hear you. A. So that one would be, what kind of transformation? That's your A value. Vertical compression. Very good. Vertical compression. Okay. Well, how do we graph this to begin with? Let's start with this one. Something that we already know, and then we can do the compression after. What's the absolute value? Absolute value of 0 is 0. Absolute value of 1 is? Absolute value of 2 is? Absolute value of 3 is? Absolute value of -1 is? 1. Very nice. Absolute value of -2 is? 2. Absolute value of -3? +3. And you've seen this before, right? On your book. The V shape. V. Okay, now, this one is going to be a vertical compression by a factor of 1/2. 1/2. Okay, so that means the x stays put, the y gets multiplied by 1/2. So everything is multiplied by 1/2. 1 times 1/2 is 1/2. 2 times 1/2 is 1. 3 times 1/2 is 1/2. Did it look like they got compressed vertically? So why are we doing this? Why are we doing this? Because most of the transformations that we've been doing is y minus k equals to a times f of b times x minus h. We don't know what the function is. We know what kind of transformation is happening, but we don't know what that function is. So I'm hoping by doing this, we can look at a specific function, and from there, we know what transformation is happening. Okay? So I'm gonna pause right here, and then we're gonna just